I'm happy to have the chance to share a little bit about the research that I've been doing in Cambria with the help of Kim and Dr. Sarah Bisbing, who are both my advisors. Unfortunately, I don't have all of the models that are essential to answering the questions that I am addressing. I don't have them all completed, but I think that today is a good opportunity to show you what we've been working on and also glean some information from some of the trends that we've noticed in all the data. So as I'm sure you are all aware of, in recent years, California has been experiencing tree die-off and drought in a magnitude that is new to the modern era. The tree die-off at this scale has the potential to transform regional landscapes and impact forest function and associated ecosystem services. Ongoing drought and predicted alteration of precipitation patterns due to climate change are likely to lead to continued mortality and a loss of species. This is especially precarious for species that are rare, endemic, and their ranges are constrained. One such species that checks off the boxes on a lot of these things is the native Pinus radiata, or Monterey pine. It is limited in its extent, and it's situated along the coast of California, and its populations are restricted from expansion due to urban sprawl. It's susceptible to drought as those populations which are already under physiological stress from insects or diseases will have increased susceptibility to drought. And Monterey pine is in fact at risk from a non-native fungal pathogen, which we know, Fusarium circinatum. Fusarium circinatum causes pine pitch canker in many native California pines. However, it's the most prevalent in Monterey pines and most widespread of any of the other species. It's found in all mainland Monterey pine populations, and it's one of the primary agents of dispersal is insects. There are many insects associated with the dispersal of Fusarium circinatum, and some species' abilities to disperse Fusarium circinatum have been proven in controlled settings and in other native Monterey pine populations, such as Monterey, California. However, the associations with insect communities in the vectoring of pitch canker has not been demonstrated in other portions of the species range, nor evaluated against the influence of other local variables. So early on, when pitch canker was first discovered in California, the prognosis was very bleak. A lot of experts estimated that the native Monterey pines would be severely decimated. However, as the decades passed and more knowledge was gleaned, we now realize that pitch canker on its own does not cause extensive mortality in trees. And throughout populations and within individual trees, there's varying levels of incidence and severity. However, the diversion of resources to fight pitch canker infection can leave the tree susceptible to other stressors. So the objectives for my project were to quantify pine pitch canker infection and determine the extent and influence of these on the local environment, native insect communities, and interactions between the environment and insect communities on pitch canker incidence in endemic Monterey pine forests. So for methods, we use repeat measure tree data from a network of permanent plots in Cambria, California. local insect and community data. And then going forward, we'll use some more statistical analysis to evaluate which factors or combination of factors are most responsible for pitch canker incidence in Monterey pines. In order to collect all of our data, we used a network of permanent plots that actually helped to implement in 2015 all over Cambria, California. The plots are established on 3 separate properties, Rancho Marino, UC Reserve, Viscalini Ranch Preserve, and Covell Ranch, which is a private ranch. Sorry, a total of 55 plots that are used in this analysis. Each plot is 17.8 meters, circular plot, and then there's a nested 8-meter plot for regeneration. The data collected consisted of quantitative measurements of trees and scales used to quantify various forest health attributes. So tree status is a neat phase scale that we borrowed from Boulder and Associates, and is we amended it to include a intermediate scale to capture flattening or dieback, which are commonly seen in pitch canker infection. And we also used a live crown estimation to assess foliage dieback. And then we tracked damage on all trees, and pitch canker incidence was determined by symptoms such as flagging, dieback, dead top, and then presence of pitch. And then in order to strengthen our claims that what we classified as pitch canker was in fact pitch canker infection, we collected samples from a subset of plots in 2017. So there were 13 plots with pitch canker present that were sampled, and it came out to about 25% of each of the property. At each plot, we sampled 2 trees that were symptomatic and 1 control tree, and on each of those trees, 2 branches were sampled. Following plating on Fusarium selective media and morphological ID, we used single spore analysis or single spore subcultures, and then did DNA extraction to do a nucleic acid analysis. And the nucleic acid analysis confirmed that Fusarium circinatum was present on all of the properties sampled. 21 of the 26 symptomatic trees had a confirmed positive test.
Matt, I want to just chime in, say about 5 minutes left.
Okay. I'll move right along. Okay, then we also implemented an insect collection to try and track insect communities and see how they might be interacting with pitch canker and mortality. And we subset 18 plots that we used stratified them by distance from the coast. We wanted 9 plots that were along the coast and 9 plots inland to try and match up with the Wickler paper that showed increased pitch canker incidence in coastal plots. And then after we collected and trapped all the insects, we sorted them, and we actually ended up trapping a few different species of known and suspected vectors, Ips plastographis, Ips paraconfusus, and then a lot of Pityopterus species. And then we attempted to isolate the Fusarium from the insects. We just used the streak method, and we tested 31 specimens, but only had 1 positive. However, I mean, one positive is still shows that some of our insects potentially would be vectoring the disease. And then just a quick snapshot of some of the trends we captured over the 3 years of the study. So in 2015, the mortality was the highest at the end of the drought. And then in 2016 and 17, mortality drops off just due to the fact that by that time, a large percentage of the trees in the plots had died, or a percentage at least. And then there was no significant difference in mortality throughout the study between the different properties. And that was determined using the Wilcoxon pairwise test. However, there was a significant difference in pitch canker incidence between the two properties, or between the three properties throughout the study period. And this goes back to the distance from the coast. Coastal plots had higher pitch canker incidences. A couple of factors could be at play. Rancho Marino, which is has some of the coast, is all coastal plots, played a large role in the difference between the properties. And Covell, which is where all the inland plots are, also has a much larger oak component and a smaller Monterey pine component. And then throughout the study period, the incidence of pitch canker increased on all plots or all properties. And so then just the conclusions and preliminary trends are that successful isolation of Fusarium circinatum on all properties. Known and suspected vector species were trapped with one successful isolation. No significant difference in mortality between properties. Pitch canker incidence increased throughout the study period, and significant difference in pitch canker incidence between the properties. Going forward, those mixed models will be essential to teasing out how pitch canker plays a role in the overall forest health and what factors are the greatest contributors to pitch canker incidence and to mortality in Monterey pines. And then we also have a insect community analysis using MMS that will help to tease out how the insect communities might be interacting with the spread of pitch canker. And thank you.